Okay, good afternoon, good morning, good evening, good night, depending on when you're watching this video. In this video, we're going to work through the exercises from lecture set 5 on working with the standard normal table. First, the standard normal table is a 2-page table. So this is page 1. You can see that page 1 is defined by the negative z-scores. So this table ranges from negative 3.9 or negative 3.90 all the way to 0 or negative 0 as the table is written, but this is just simply 0. The second page are the positive z-scores. So this page starts at 0 and goes up to 3.90. Every value inside the table, so every single 4-digit decimal point inside the table, these are all areas underneath the standard normal curve. The table gives cumulative area. So it starts from what would be considered 0 area underneath the curve, which is the lowest possible value. You can see that this is 0 to 4 decimal spots with a little asterisk that says the areas are 0.0002 decimal places. Technically, the area is never exactly equal to 0, but up until 4 decimal points, it's approximately 0, and that's where the table begins. Okay, now as we work our way through the table, we progressively get more and more area underneath the curve. So you can see that as the z-scores get closer to the 0 value, we're at 0.5% of the area underneath the curve. Okay, and then as we continue to work across the positive page, we increase from 0.5 up until 1. Okay, so all the area underneath the curve, but again, only to 4 decimal places of accuracy. Now, our intention with this table, or with these two tables, well, 2 pages for one table, are to find different areas underneath the standard normal curve. So we're going to illustrate how the table works using these 4 illustrations given on slide 20. So these are progressively going to get more difficult, starting with using the table fairly directly and then working our way up to more difficult styles of problem. Okay. So question 1. Find the area to the right of 2.09. All right, so with any standard normal problem, the first thing we want to do is sketch a standard normal curve and then highlight the area that we're looking for. Okay, so this is going to be my sketch of the standard normal curve. So that's just a bell curve. And every standard normal curve is centered at 0. So this gives us a reference point for where we can mark the values that we're looking for. We want the area to the right of 2.09. So if 0 is the mid part, let's say 2.09 is right about here. We don't have to be super precise with this. We just need to give ourselves an idea of what we're looking for. And we want the area to the right. So that is this area shown here. So we're looking for this red shaded part here. Okay. So this area is also a probability. So strictly speaking, we are looking for the probability that a z-score is greater than 2.09. So this is actually what we're going to find. Okay, every standard normal table gives you area to the left. So if we look up 2.09 in the standard normal table, okay, so we start here. This table is giving us negative values. So this is not what we want. We go to the second page. Okay, this table is giving us positive z-scores, which is what we want. So we scroll down. Here's 2.0, and then we go across to 0.09. And then we intersect with those two values. So that gives us this quantity here, 0.9817. So this is the area to the left of 2.09. Okay, so the table always gives us area to the left of the z-score. All right, so when we look up z equals 2.09, we find the area to the left of 2.09 is 0.9817. This is the probability z is less than 2.09. Okay, so we have the probability z is less than 2.09 equals 0.9817. We want the probability z is greater than 2.09. Okay, well, total area under the curve must equal 1 because it's a continuous probability density curve. So therefore, the probability that z is greater than 2.09 is going to be 1 minus the probability that z is less than 2.109. Okay, so therefore, the probability z exceeds 2.09 is 1 minus the probability z is less than 2.09, which is 1 minus 0.9817, which is 0.0183. Okay, and then this is our answer. So the size of this red shaded part here is a size of 0.0183, and that is also the probability that z is greater than 2.09. This area is a size of 0.0183. All right. Now, in general, when we're answering these types of problems, it's fine to just give the probability statements with the sketch. We don't need to go through all of the explanation regarding what the values represent. This is simply for clarity to help us as we work through the more complicated problems. Okay. All right, so number 2. It's a very similar style of problem. So it says, find the area between negative 1.645 and 2.0. All right, so the first thing we're going to do is sketch out our standard normal curve. Okay. So again, every standard normal curve is centered at 0. That's our reference point. We want the area between two z-scores. So we have a negative z-score. So this is negative 1.645. And then we have a positive z-score, which is 2.00. Okay. So between those two z-scores is going to be this area here. Okay, so this is what we want. Okay, so in terms of a probability statement, what we have here is the probability negative 1.645 is less than z is less than 2.00. Okay, so this is what we're looking for in the context of a probability statement. All right. With this type of problem, what we can do is we can look up both z-scores and subtract the smaller z-score from the larger one. So as you might recall, the table gives us area to the left. So when we look up 2.0, we are going to get the area below 2.0 all the way down to negative infinity. When we look up the area at negative 1.645, we're going to get the area below negative 1.645 to negative infinity. So we can subtract off the area below or to the left of negative 1.645 from the area to the left of 2.0, and that's going to give us the area in between, which is what we want. So in terms of probability statements, this is the probability Z is less than 2.0 minus the probability Z is less than negative 1.645. All right. So now all we have to do is look up these two values in our Z-score table. We get the areas underneath the curve directly, and then we can just subtract the smaller area from the larger one. So we'll start with 2.0. That's going to be on the positive side. Okay. So in our previous illustration, we already found 2.0. So we just need to find that second zero, which is in the first column. So this is going to be the value that corresponds to 2.00. Okay, so the area to the left or the area below 2.00 is 0.9772. Okay, so this is 0.9772. All right, and now what we have to do is find the area to the left of negative 1.645. Okay, so this is a 3-digit Z-score. All Z-scores in the table are 2 digits. So what's going to happen here is we are going to average the 2 Z-scores that fall an equal distance from negative 1.645. So here's negative 1.6. Here's 0.04, and here's 0.05. So this is, when we match them, negative 1.64, and this is negative 1.65. Okay, so we want the area in the middle of these two quantities. Okay, so we want the area between, or the average of 0.0495 and 0.0505. So here we're going to have 0.0495 plus 0.0505. Okay, and we're going to average these, right? So we're adding two values together and dividing by 2. So now we have 0.9772 minus 0.05, which is 0.9272. Right? And then this is the solution to the problem. We only have to average when we are asked for 3-digit decimal points where the third digit is a 5. Okay. If we are asked for example, if we have a Z-score that does not have a 5 in the third decimal spot, so for example, negative 1.646 or negative 1.643, then we can just round to the closest Z-score. Okay, so this is a special case. The negative 1.645 is a special Z-score that's going to come up a number of times throughout the remaining part of the semester. So this is just a particular value you want to be able to work with. But in most cases, we're going to have Z-scores where the third decimal point is either above 5 or less than 5. And in those cases, you can just round. All right, let's continue with our examples. So the third example, find the area below negative 1.645 and the area above 1.645. Okay. So here, we start by sketching our Z-curve. Okay, and now we're going to mark down our two values. So we have 1.645 and we have negative 1.645. All right, so we want the area above positive 1.645 and we want the area below negative 1.645. Okay, so we want these two areas. So this is the probability Z is less than negative 1.645 and the probability Z is greater than and Z is greater than 1.645. Or actually, this is going to be 4. Okay. Okay, so we want both areas. Okay. So this is the probability Z is less than negative 1.645 plus the probability Z is greater than 1.645. And so these are the two areas that we want. Okay, so in order to find these, what we have to do is go back to our Z table again, and we just need to look up these values. Now, in the first case, we have less than the negative. So the table is going to give us directly this quantity. As we had just discussed, when we look up negative 1.645, we're taking the average of these two quantities here. So because the third spot is the third decimal spot is a 5, negative 1.645, we average two z-scores. So we're going to average the probabilities for 1.64 and 1.65. And as we just saw, this is going to be 0.0495 plus 0.0505 divided by 2. All right, I'm just going to move this down. Okay, and then we're going to add this to. Now, in the second case, we have the probability Z is greater than 1.645. All right, so we go to our positive Z table now. Here's 1.6, 0.04, 0.05. Okay, so now what we want is the average of 0.9495 and 0.9505. All right, so here we will have 0.9495 plus 0.9505 divided by 2. Okay, now this is area to the left of 1.645, but we actually want the area to the right, which you can see from the diagram and the probability statement. Okay, so that's area to the right, 1.645. Area to right. So what we have to do here is simply subtract this average from 1. So now what we're going to have is 0.050 plus 1 minus 0.9500, which is equal to 0.0500 plus 0.0500, which is 0.1000. Okay. Now, in this question, you actually can also take advantage of the symmetry of the curve. So because the standard normal curve is symmetric around 0, the area to the right of positive 1.645 is equal to the area to the left of negative 1.645. Okay. So since curve is symmetric, the probability that Z is less than negative 1.645 is equal to the probability that Z is greater than positive 1.645. Okay, so those two quantities are the same, which is what we showed in our initial solution. Okay, so therefore, the probability that Z is less than negative 1.645 or Z is greater than 1.645 is equal to 2 times the probability Z is less than negative 1.645, which is also equal to 2 times the probability Z is greater than 1.645. Okay. So in this problem, we actually could have just looked up the probability that Z is less than negative 1.645, which is equal to 0.05, multiplied that by 2 because of the symmetry of the curve, and we would have ended up with the same solution. Okay, so we can take advantage of the symmetry of the normal curve when we're looking for area below and above certain Z scores, below and above Z scores that are the same magnitude or have the same absolute value. All right, so last problem is very similar to the third problem, except that we can't take advantage of symmetry here. So in the last problem, we want the area below negative 1.85 and above negative 0.56. So this problem is going to work in the exact same way as the previous one, except that we no longer can use the symmetric property if we wanted to. Okay, so if we sketch this out, this is 0, and we have negative 1.85, and we have negative 0.56. I'm just going to make this. I guess I'll just move this over a bit. Okay. Again, the sketches don't have to be exact. It's just so that you have an idea of what you're looking for. Okay, so we want this area here, and we want this area here. Okay, so what we want is probability Z is less than negative 1.85, or the probability that Z is greater than negative 0.56. Okay. So this thing is the probability that Z is less than negative 1.85 plus the probability that Z is greater than negative 0.56. Okay, so this is going to work in the same way as the previous problem. The first thing we'll do is look up negative 1.85. Okay, so here's negative 1.805. Okay, so we're going to match that value up, and that gives us 0.0322. Okay, so the area to the left of 0.0322, so the probability that Z is less than negative 1.85 is 0.0322. Okay. Now we're going to look up negative 0.56. Okay, so here's negative 0.5. Here's 0.06. Okay, so the area to the left of negative 0.56 is 0.2877. So the probability that the Z score is less than negative 0.56 is 0.2877. But we want the probability that the Z score is greater than. So we need to 1 minus this quantity, because again, the Z table is always giving us area to the left. So this becomes 0.0322 plus 0.7123. Okay. Should probably just check that. I think that's fine. Don't trust my math anymore. All right, and then we add these together and we end up with 0.7445. Okay, so the area to the left of negative 1.86 plus the area to the right of negative 0.56 is 0.7445. Okay, if we wanted to take advantage of symmetry here, what we could do is say probability that the Z score is greater than negative 0.56 is actually equal to the probability that the Z score is less than 0.56. Okay, and then if we go to the positive table and we look up 0.56, there's our 0.7123. Okay, so this would be an alternative way of working through the solution. All this would really do is prevent you from having to subtract from 1, which is not a big deal mathematically. But this would be another way to work the problem if you wanted to take advantage of the symmetry. Okay, and then you can solve. All right, so those are 4 illustrations of finding area underneath the standard normal curve. Finding area underneath the standard normal curve is a very important technique that we will use often throughout the course. We're going to see it often or in another illustration in this lecture set. We'll see it again when we start talking about sampling distributions in lecture set number 6. And then we'll see it again when we start talking about confidence intervals and hypothesis tests for 1 and 2 samples when the population standard deviation is known. But that's a few weeks away. Okay, so as always, if you have any questions, please let me know.